Okay, in this video, we are going to talk about domain and range. So this is something that has to do with functions. We've been talking about functions. The domain is all the set of possible inputs. So it's every number you can put into the function. What did we say that the inputs were? X values. So these are all the possible X values. So when you see the word domain, you think X, and X happens all along the X-axis. So you could think domain, what X values can I use, okay? The range of the function is all of the possible outputs. What comes out of a function? The Y values. So the Y values are the range, and on your graphs, you might even write, range going vertically, because that's going to be all of your values of Y. Y, X, right? Okay, the interval and set builder notation. These can get really confusing for students. So sometimes an answer to a mathematical question is not just a single number. It could be a set or a range of numbers. For example, one might only hire a babysitter who will work for $10 to $15 an hour. There is a shortcut for stating this pay range. So, because if I will work for $10 an hour, how many different possibilities of pay are there between $10 and $15? Like, what would be some possibilities of numbers that I would accept if that's how much you're going to pay me to babysit your kids? 11, 12, 13. Would I also accept $14.50? Would I also accept $14.75? Would I accept $14.99? Yes, anything in between. So what this means, this is an interval, and it's saying it starts at 10, it ends in 15. We call this interval notation. Okay, another way of saying this is set builder notation. X, this line right here reads as such that. So you're saying X could be a number in between 10 and 15. You see how X is in between 10 and 15? This says 10 is less than or equal to X, and X is less than or equal to 15. So on a number line, it would look like this. Here's 10, here's 15. There's actually an infinite number of numbers in between those two numbers, including 10 and 15. Okay, so if we look at these other number lines, all real numbers greater than 2. Now ask yourself for a minute, all real numbers greater than 2. Give me a number that's greater than 2. 3, what else? 4, 2.5. Is 2 greater than 2? No. So we actually put a parenthesis on the 2. That means the number is not included in the set, okay? The interval will be from 2 to infinity. This is where it starts, and this is where it stops. And we always go small to high, okay? Least to greatest. This says all numbers less than 8 or equal to 8 on a number line. So, and this is probably just, I don't know what happened with the spacing, but it's probably just this thing got in the way. So here, less than 8. What are some numbers that are less than 8? Let's put them on here. 7, 6, 5, 4, 3. Where does it end? That arrow keeps going on and on and on and on. Negative infinity. And that's actually, I shouldn't say where does it end. I should say where does it begin? That arrow is talking about where the beginning is. The smallest number is going to be negative infinity. The biggest number is 8. And that 8 means, this bracket right here means the number is included. Now, how come I didn't put a bracket around infinity? I forgot to mention why I just put a parenthesis around infinity. Why should I not put a bracket around infinity? Because you can't ever get to infinity, right? Infinity is actually not a place, it's a concept. So if I put a bracket around infinity, that would mean I included it, but I can't include it because I can never get there. So the parenthesis means the number is not included. The bracket means the number is included. So that's why we include the 8. And then all real numbers except 4 can be expressed. So here's everything on the number line is shaded except 4. So that means it starts at negative infinity. It goes up to 4. Are we including 4? No. So we put parenthesis around 4. We skip 4. Then we use this U right here. The U means union, means or, from 4 to infinity. That's the interval notation for that. Okay? I don't know why I have these blanks right here. For the given graphs, write the solution in set notation. Okay, so if I only have, notice that nothing on this graph is shaded. Only the 2 and the 4 are the numbers. So that solution set is 2 and 4. That's actually not an infinite set, right? That's just 2 numbers. And that's because these 2 numbers are included in circles, but nothing else is included on that line. For this example right here, we're going to give the interval and the set notation. So look at the, here we have what's shaded is in between the 2 and the 5. And we know there's an infinite number of numbers between 2 and 5. So what would that interval look like? Where does it start? And I put a bracket around that, and then it stops at 5. So there's no infinities there. Okay? Now this is saying that x could be anything in between. So our set builder is solution set x such that, and x is in between 2 and 5. So here's the 2, here's the 5. 2 is less than or equal to x is less than or equal to 5. That's a compound inequality. We're putting 2 inequalities together into one. Now here, everything is shaded before 1. We skip from 1 to 4, and then we shade above 4. So down here is negative infinity. Up here is positive infinity. What's the interval going to be? Can anyone tell me? Negative infinity to 1. Good. Parenthesis, union, 4 to infinity. Excellent. What about the set builder notation? This is a little bit tricky. X such that, there's a couple of different ways you could probably write this, but I'm just going to write it as x is less than 1 or x is greater than 4. Because I'm not putting x in between the 2, right? It jumps over the 1 to 4 area. Okay, any questions about that?